Hi friends, welcome to our YouTube channel Agricultural Engineering. So we are going to continue our chapter that watershed planning and management. Now we are continuing with module 8. So soil erosion and its control measures. So what are different types of soil erosion? See, types of water induced soil erosion. There are raindrop erosion. So in this case, they will ask the raindrops sometimes fall at height speed of 50 km per hour and the soil particles may be splashed to a height of 60 cm and move laterally to a distance of 150 cm. So first type of erosion is raindrop erosion. See, the raindrop velocity depends upon the height of fall up to a height of about 10.5 meter, after which it attains the terminal velocity. Soil loss increases with the increase of this terminal velocity, which may vary from 4.5 to 9 meter per second depending upon the drop size. Now another one is sheet erosion. Sheet erosion has been defined as the uniform removal of soil in thin layer from sloping land, which results in sheet or overland flow occurring in thin layers. So this is definition of sheet erosion. Then rill erosion. Rill erosion is also called the second erosion, in which the removal of soil by rainwater from small but well demarcated semi-permanent channels or streamlets takes place due to overland flow. Another one is gully erosion. If the rills are not attended for a longer time, they develop further in their depth and width and finally form gullies. Uh, this is the advancement of gully depends upon watershed characteristics, rainfall characteristics, soil characteristics, shape of the gully, slope of the channel, and cultivation practices in watershed. So these are four stages of development of gully. Remember this. First is formation stage. Channel erosion takes place by downward score of the topsoil. If the topsoil can provide resistance, this stage proceeds slowly. Another one is development stage. Upstream movement of the gully head and simultaneous enlargement of width and depth take place. Healing stage, vegetation begins to grow in the channel and further erosion stops. Stabilization stage, the gully bed and sides reach a stable slope and sufficient vegetation grows to anchor the soil and to trap the soil flowing from upstream. So from exam point of view, there is chance they will ask what are different four stages of development of gully and arrange them in sequence. So first is formation, then development, then healing, and then stabilization. So what are different types of classification of gullies? So on the basis of shape, there are two classes, V-shaped or U-shaped. V-shaped gullies are formed due to scouring of soil by concentrated runoff in unprotected depressions. If both the surface and subsurface soil are easily erodible, then U-shaped gullies are formed. So these are two types. Then according to this classification, one more classification is there. Very small gullies have depth and widths within 3 meter and 18 meter respectively. Small gullies have depth within 3 meter but width is depth within 3 meter but width is greater than 18 meter and side slope may be between 8 to 15%. Medium gullies have depth between 3 to 9 meter, bed width 18 meter or more. Deep and narrow gullies generally have depth 3 to 9 meter and bed width less than 18 meter. So remember this classification. After that, measures for water induced soil erosion control. So contour cultivation we can do to avoid soil erosion. Then contour bunding. From bunds, remember one thing you should know: bunds, trenches, at what slope they are constructing bunds and trenches, and what is the rainfall of that particular place, and what different types of crop plantation happening uh, uh, nearby that particular construction. So you should know that things. So here design of contour burns, spacing of contour burns, Ramsar formula. Remember Ramsar formula. Vi is equal to 0.3 s by 3 plus 2, where Vi is vertical interval between consecutive burns and S is land slope in percent. Then Cox formula, Vi is equal to xs plus y into 0.3 So for that, rainfall conditions scanty, moderate, heavy, value of X, and annual rainfall they have given. So for value of Y also they have given values. So what should be the spacing of contour bunds? So according to land slope, the vertical interval changes, and approximately horizontal distance also changes. After that, graded bund. See, in the areas of high rainfall, annual rainfall greater than 800 meter, there uh, for soil erosion, controlling soil erosion, graded bunds are constructed. Then these are some of the construction of graded bunds. Now terraces. See, bench terraces are constructed to divide a steeply sloped hilly land into a series of level or nearly level strips or benches running across the slope. So bench terraces are constructed on steep slopes greater than 6 to 7%, although recent recommendations favor their construction on slope greater than 15%. So what are the components of bench terrace? Riser, outlet channel, platform, and shoulder bund. So what are different types of bench terrace? Remember, I am again repeating, this is the important point from ICAR exam point of view. So there are three different types of bench terraces: level bench terrace, outward sloping bench terrace, and inward sloping bench terrace. So level bench terrace, they are also known as tabletop or paddy terraces. Remember the another name of level bench terrace. And they are generally used in paddy cultivation, as paddy requires some ponded water on a land of very mild slope such as 1%. Also, level bench terrace is constructed to facilitate paddy cultivation. The level type is suitable in area with medium rainfall and permeable soils. Now another one is outward sloping bench terraces. In areas of low rainfall or shallow soil depth, this type is suitable. The existing steep slope can be reduced to a mild slope to reduce soil erosion, conserve soil moisture, and grow crops other than transplanted paddy. There is one more name for outward sloping bench terrace. Please just refer book once to get the name, another name of outward sloping bench terrace. Then inward sloping bench terrace. In high rainfall areas with steep slopes, this type of terraces may be used, and vegetated waterway is used to dispose of the water from such drains in inward sloping bench terraces. Now California type terraces. This is also known as Puerto Rican type terrace. At first a vegetative or a mechanical barrier is established along the contour. Then the soil is plowed and pushed downward gradually during tillage operations every year. Then another one is Tati terrace. The Tati terrace was first adopted in Tati village near Chandwa in Palamau district of Bihar by the Soil Conservation Department of the Damodar Valley Corporation. So this is another type. Now what are the methods? Grassed waterways. Vegetated or grassed waterways are used for safe disposal of runoff from field, traced areas, diversion channels, spillways, or other structures. So what is the function of grassed waterways? You just go through that. Then what are different shape of grassed waterways? Generally parabolic, triangular, and trapezoidal shapes are used for waterways. Natural waterways have a shape very close to parabolic shape. Trapezoidal channels after long use gradually approximate to the shape of parabola. So channel grade and velocity. So now we will move towards now wind erosion. Now see, these are type of soil movement due to wind: suspension, saltation, and surface creep. So suspension fine dust particles with diameter less than 0.05 mm are submerged in the laminar zone of airflow, and therefore they cannot be moved by direct action of the wind. Then saltation, the direct action of wind on the soil particles and their collision with each other particles create somersaulting soil movement known as saltation. Then surface creep, coarser soil particles having a diameter range of 0.5 to 2 mm are too heavy and cannot be lifted up by wind action. Therefore, they can move neither by saltation nor by suspension. When the particle moving due to saltation strike them, they are pushed along the ground surface. This type of rolling or sliding of heavy particles along the ground surface is known as surface creep. So major portion of the soil erosion by wind takes place in saltation. Remember this. It may vary between 50 to 75%. Suspension may erode between 3 to 40%, whereas surface creep may be between 5 to 25%. So what are the measurement to avoid this one? One is cultivated crops, then stubble mulching, then field strip cropping or contour strip cropping. Now here a definition: field and contour strip cropping consist of alternate strips of row crops and close growing crops in the same field. So there is chance they will ask for fill in the blanks. Dash cropping consists of alternate strips of row crops and close growing crops in the same field. So remember, this is answer is field strip cropping and contour strip cropping. Now wind breaks, then shelter belts. These are measures for avoiding wind erosion. Then other tillage practices. Now sediment yield estimation and measurement. So sediment generation and transport mechanism in watershed. So these are the transport mechanisms: suspension, saltation and surface creep. Suspended sediment is that which remain in suspension in the flowing water for a considerable period of time without contact with the stream bed. Then saltation, movement of sediment along the stream bed because of bounce and skip on the bed. Surface creep, it is movement of sediment almost in continuous contact with the stream bed. So these are types of sediment transported along with stream: wash load, suspended load. In this case you can see the particle size: coarse sediment, medium sediment and fine sediment. Bed load. Then method of stream sediment measurement: sampling. In this case sample collection. These are method for sedimented soil sampling: basket type sampler, tray type sampler, pressure difference type sampler. So these are the different type of sampler used for sampling the load. Then dissolved load, suspended load, intermittent suspension load, wash load, bed load. So this is not that much important, we can skip this one. This is one equation, USL equation, RKLSCP. You should know each and every term. R stands for rainfall factor, K, what is the K? Soil erodibility factor. L is slope length factor. S is slope stiffness factor. C is factor related to cover management, and P is factor representing the supporting practices applied. Then SWOT model, soil and water assessment tool. Now what are the in situ rainwater conservation techniques? Rainwater harvesting, roof water harvesting, then storage tank dye season, demand versus supply. So you just once go through this one. This is not that much important. Design of rainwater harvester structure is also not that much important. Now water budget. What is meant by water budget? You should know: evapotranspiration, runoff. Then what is the formula? This you should know formula. Precipitation is equal to surface runoff plus actual evapotranspiration plus interflow plus groundwater discharge plus anthropogenic inputs plus delta I, change in land surface storage, delta S plus delta G. So this formula for water budget, remember that one. Now agriculture practice, land use, land cover image. This is part of remote sensing and GIS. So method of how we can estimate land use and land classification, aerial photographs, remote sensing imaginary. Then how to process. This is a practical example how to use remote sensing and GIS for land use, land classification, land cover, land classification. Then participatory rural appraisal, PRA. So just go through this one. I think you can expect one question from this participatory rural appraisal. Then these are some of the case studies, no need to go through this. Then monitoring of watershed programs, so this is not that much important. Then evaluation of watershed program, no need to go through this. Then what are the benefits? In this case there is no point to prepare questions from this. Here discounting factors, just go through this capital recovery factor, these points, discounting factors. Once you go through benefit cost ratio, then rate of return method, just see, don't go too much deep because you can't expect any question from this topic. No, okay, so in this way we have completed this watershed planning and management. In upcoming lecture we will come up with different course. Thank you for watching our video.